The internet connects billions of devices worldwide. It's a massive network of networks. But how does it all work? The answer lies in a set of rules called the TCP/IP protocol suite. TCP/IP stands for Transmission Control Protocol, Internet Protocol. Think of it as the language that computers use to talk to each other online. Without TCP/IP, the internet as we know it wouldn't exist. TCP/IP is essential because it provides a common standard for communication. Imagine trying to understand someone speaking a language you don't know. That's what it would be like for computers without TCP/IP. With TCP/IP, all devices on the internet can communicate seamlessly, regardless of their operating system or hardware. The TCP/IP model has 4 layers: application, transport, internet, and network interface. Each layer performs a crucial role in internet communication. The application layer is the top layer. It's the layer that users interact with directly. Applications like web browsers, email clients, and video streaming services use this layer. They use it to send and receive data over the internet. The transport layer is responsible for end-to-end communication between applications. It ensures that data is delivered reliably and in the correct order. The 2 main protocols at this layer are TCP and UDP. TCP is connection-oriented, meaning it establishes a reliable connection before transmitting data. UDP is connectionless and is used for applications where speed is more important than reliability. The internet layer, also known as the network layer, handles the addressing and routing of data packets. This layer is where IP comes in. IP addresses are unique identifiers assigned to every device on the internet. Routers use these addresses to determine the best path for data to travel across the network. The network interface layer, also called the link layer, is the bottom layer of the TCP/IP model. It's responsible for the physical transmission of data over the network. This layer includes protocols for Ethernet, Wi-Fi, and other network technologies. Every device on the internet needs a unique address to communicate. This is where IP or Internet Protocol comes in. An IP address is a numerical label assigned to each device connected to a computer network. IP addresses serve 2 primary functions: host or network interface identification and location addressing. Think of IP addresses like street addresses. Just as a postal service uses a street address to deliver mail to the correct location, computers use IP addresses to send data to the right destination on the internet. When you send an email or visit a website, your computer uses IP addresses to route the data to the correct server. Routers are like the postal workers of the internet. They are specialized computers that direct traffic between networks. When a data packet travels across the internet, it passes through multiple routers. Each router examines the packet's destination IP address and consults its routing table to determine the best path for the packet to take. TCP, or Transmission Control Protocol, is a fundamental protocol in the TCP/IP suite. It provides reliable and ordered delivery of data over the internet. TCP is a connection-oriented protocol, meaning that it establishes a connection between 2 devices before transmitting data. One of the key features of TCP is its error-checking mechanisms. When data is sent over the internet, it's broken down into small packets. TCP ensures that these packets arrive at their destination in the correct order and without any errors. If a packet is lost or corrupted during transmission, TCP requests a retransmission. Think of sending a large document as an analogy. Imagine tearing the document into many pieces and sending each piece separately. TCP would be responsible for numbering the pieces, putting them back together in the correct order upon arrival, and requesting replacements for any missing or damaged pieces. TCP and IP work together to ensure reliable internet communication. IP handles the addressing and routing of data, while TCP ensures that the data is delivered reliably and in the correct order. Please let us know in the comments if you have a suggestion for our next video. Also, if you enjoyed this video and want to see more content like this, make sure to hit that like button, and don't forget to subscribe our channel so that you won't miss any of our future videos. Stay connected and keep learning.